Hi, my name is Claire Jantz. I am a professor in the Geography Earth Science Department at Shippensburg University, and I'm also the director for the Center for Land Use and Sustainability at Shippensburg University. This is one of two webinars that I have put together with support from the William Penn Foundation to support the Delaware River Watershed Initiative. Many of us use land cover data in our work in the DRWI, and many of us use the National Land Cover data. So this webinar focuses on the new edition of the National Land Cover data and how it compares to the old edition, and also suggests some best practices. The second webinar focuses on the high resolution data set that was produced by the University of Vermont Spatial Analysis Lab. So to get started with this comparison of national land cover data sets, first of all, in May of 2019, the USGS released the latest version of the national land cover data. And this is referred to as NLCD 2016. This new data product has a similar look and feel of as the edition that we're used to working with, which is the NLCD 2011, because for the categorical land cover data products, the class definitions are consistent. However, the mapping methods have been completely overhauled, plus there's a few new products available with NLCD 2016. Couple things to keep in mind: the overall accuracy of the categorical land cover maps with NLCD 2016 is 71 to 97%, depending on the class. This is an improvement over NLCD 2011. It's also important to keep in mind that the 2016 date did not go through a thorough accuracy assessment, and so the USGS considers this product provisional. However, the previous dates did go through an accuracy assessment. So many of you are probably familiar with what I've been calling the categorical land cover data sets. This is the data set that has multiple 16 categories of land cover classes, as you can see on the legend here. All of these products within NLCD 2016 are seamless for the continental US and are at a 30-meter resolution. The land cover maps have a more refined timeline. So we have 6 time steps: 2001, 03, 06, 11, 13, and 16. Plus there's a change index map that indicates land cover changes that occurred at least one time between 2001 and 2016. And I'll show a couple of examples of that in a second. There's also, like the 2011 product, the 2016 edition includes urban imperviousness products. And with these products, there's an estimate at every single pixel, the percentage of developed impervious surface within that 30-meter pixel. These are available for 2001, 2006, 2011, and 2016. So not for the full time series, for a subsection of the time series. And that is important to keep in mind a little bit later. New to 2016 is a descriptor layer that identifies the types of roads, core urban areas, and energy production sites for each impervious pixel. And again, I'll show some examples of this. So this is on the left, we're looking at the impervious surface percentage data product for 2011. And each pixel has an impervious surface area value that ranges from 0 to 100%. And on the right-hand side is the impervious surface descriptor layer, where you can see that they have pulled out non-road impervious surfaces in urban areas, outside of urban areas, primary road in and out, secondary road, and so on. So if you're interested especially in impervious surfaces, this is potentially a good data set to look to. In terms of that change layer that I referenced earlier, this is a snapshot of what you get there. So again, this is any change that occurred between 2001 and 2016. You can see there's 12 different types of changes captured here that happened at least one time during this time period. A couple of other products available. Like 2011, the 2016 edition includes tree canopy products that estimates the percentage of tree canopy for every 30 meter pixel. These are available for 2011 and 2016. And then for the Western continental US, and only for the date 2016, there is a suite of shrubland products. This is primarily to help with fire threat monitoring and modeling. So that's the overview of 2016. Let's take a look at how the new edition compares with the old edition. So what we're looking at here is for the date 2011. On the left-hand side is the 2011 edition of NLCD. On the right-hand side is the 2016 edition. And you can see, obviously they look very similar, but there are some places where you'll notice differences in how they map some of the land cover categories. For example, you'll see like yellows and browns, there tends to be some differences. Those are agriculture classes and scrub classes. And in the greens, there also seems to be some differences there. So you can definitely notice differences at the pixel scale. So I wanted to see what these differences look like at the scale of the basin. So when we look at the scale of the whole basin, again, the 2011 edition is in orange, the 2016 edition is in blue, and this is a comparison of the area of each land cover type that these two different editions estimate for the year 2011. And for the most dominant land cover type in the basin, that's deciduous forest, the estimate from the 2016 edition is more than 900 square kilometers higher lower than the estimate for the 2011 edition. So that's a difference of about 7%. The mixed class forest, on the other hand, is more than 2 times higher than it is for the 2011 edition. And so again, we see some of that class swapping. When we look at forest classes combined, and here I'm going to show you guys a table. This table is showing each of the land cover categories. The next set of 3 columns is a comparison of 2001. The next set of columns is a comparison of 2006. And the third set of columns is a comparison of 2011. And it shows the area in square kilometers for from each product, as well as the percent difference. So when we look at the combined, for example, forest classes, you can see that the 2016 edition estimates between 4 and 4.31% more forest than the 2011 edition for the 2001 to 2011 time period. Agricultural classes combined are estimated to be 1.58 to 2.33% lower in the 2016 edition for 2001 to 2011, and urban classes combined are about 1.5 to 2% lower in the 2016 edition compared to 2011. It's important to note that these differences are largely due to differences in mapping methodologies between the two editions. All of the same imagery is used, so it's really just coming down to differences in how the mapping algorithms worked. So, so that's going to be something for messaging that we'll talk about in a little bit. If we look at example trends. On the left-hand side, we're looking at trends over time for developed open space. On the right-hand side, trends in deciduous forest. And you can see the 2011 edition is in orange, the 2016 edition is in blue. And you notice a couple of things. First of all, the trends are overall the same. So developed open space is increasing in both products, while deciduous forest is decreasing in both products. You do see differences in the amount of each land cover type that is estimated in each product. You also see a more frequent time step in the 2016 edition than you do in the 2011 edition. However, when you look particularly at the developed open space, you can see, for example, that there's no change recorded between 2001 and 2004. The only change you see in that early time period is up to 2006. And again, that's because the impervious surface classifications were not run for the full set of dates. It was only run for a subset, so we're missing changes in that time period. If we drill down a little bit and look at how these two editions differ over space, this is looking at differences between the 2011 and 2016 editions at the scale of Huck-10 watersheds. So these are relatively large watersheds, but it does allow us to see differences in these two products. In this case, we're looking at the developed classes. So the first map is developed open space, and then we have developed low intensity, medium intensity, and high intensity. And the last map on the right shows all classes combined. When we're looking at this, the orange colors are when NLCD 2016 estimates more of that land class relative to 2011, and blue is when it's estimating less relative to 2011. And we can see that for low intensity, medium intensity, and high intensity, these two products are within 0.5% of each other across the entire basin. So most of the differences that we see here are due to the developed open space category. In the northern part of the Delaware River Basin, the 2016 edition tends to estimate more developed open space than the 2011 edition. And the reverse is true in the southern part of the basin. This is probably because developed open space is spectrally similar to some other classes, like some of the agricultural classes. And it's also possible that in the northern part of the basin, the 2016 edition is better able to discriminate between open space development and forested landscapes that are kind of intermixed with developed land cover. So this is for the developed categories. When we look at agricultural categories, again, we interpret these maps the same way. Orange is when 2016 estimates more of these classes relative to 2011. Blue is where it estimates less. The first map is pasture hay, the second map is cultivated crop, and the third map is all classes combined. So again, we're seeing some evidence of class swapping, and we're also seeing that in the middle and lower part of the basin is where we see the most significant differences here. This is also almost a switch of the patterns that we saw in the urban maps. And that difference in patterns is also pretty apparent in the forest classes. So here we have deciduous, evergreen, mixed, and then all forest classes combined. Again, interpreted in the same way. Now, if we look at urban, forest, and agriculture, it's also interesting to look at the degree of variability. For any given watershed, differences in urban classes don't really exceed plus or minus 2.5%, but the differences in agriculture and forest classes can exceed plus or minus 17%. So a lot more variability in the agriculture and forest classes when we're comparing these two products. Another thing that I found is that when we look at finer scales, so when we continue to zoom in, variability and the differences between these two products increases. So if we zoom into NHD catchments, these are much smaller watersheds than the Huck 10 watersheds. These are box plots that show the difference, the percent difference between 2016 and 2011. The blue box plot is the difference calculated at the Huck 10 scale, while the orange is the difference calculated at the NHD catchment scale. And in this case, we're looking at the urban difference. We can also see, and here you can see that, you know, this is plus or minus 100% at the NHD catchment scale for at least one of those small watersheds. This is what we see for agriculture, and this is what we see for forest. And if we look at a map, there's again some of that the changes that we saw at the Huck 10 scale are visible, but at a much more refined scale in this case. As we saw, individual catchments can vary as much as plus or minus 100% across urban, forest, and agriculture, but the forest class shows the highest variability. In the forest class, differences frequently exceed plus or minus 40%, while differences in the urban and agricultural classes exceeding plus or minus 25% are pretty rare. When we look even closer at the pixel by pixel comparison, what we're looking at here is what's called a confusion matrix. The rows show pixels that are mapped as different land covers in the 2011 edition, and then the columns show the 2016 edition. And this is a pixel by pixel comparison of the year 2011, a date that they have in common. The class with the highest rates of agreement, you can see, are water. So in the case of water, over 96% of the pixels are mapped the same in both editions. Another high agreement class is developed high intensity, where we see an agreement of over 91%. If we keep looking at the developed classes, developed open space has the lowest agreement between the two editions, where we see about 72% agreement. And in this case, just over 10% of the pixels mapped as developed open space in the 2011 edition are mapped as deciduous forest in the 2016 edition. We also see areas of confusion with pasture hay, mixed forest, row crops, and develop low intensity, and that's largely due to the spectral similarity of the developed open space category to those other classes. If we keep looking down through this matrix, the lowest area, the class with the lowest agreement is the shrub scrub class, where the two editions agree across just 18% of the pixels in this category. In this case, the highest rates of confusion are with deciduous forest and mixed forest. Again, spectral similarity between those classes causing that confusion. We also see some class swapping with grassland herbaceous, pasture hay, and row crops, where, for example, overall agreement in the grassland herbaceous class is 28%, where 22% of the pixels mapped as this class in the 2011 edition are mapped as pasture and hay in the 2016 edition. You can see similar patterns like that in the three forest classes. So this pixel by pixel comparison kind of puts numbers on, you know, where the class swapping and differences are occurring between the two products. So again, we do see changes or differences between NLCD 2011 edition and the 2016 edition. So when we move forward with what the take-home lessons and best practices are, first of all, we are all going to have to adopt the 2016 edition product. The 2011 edition is now a legacy product. It's no longer supported by the multi-resolution land characterization program, and you can't even download it from that website anymore. So that means we need to look at 2016 as our new baseline. And this is a snapshot that looks like in terms of land cover classes from NLCD 2016 edition. Couple of things to highlight here. First of all, the biggest changes we see are in forest, agriculture, and the urban developed classes. Urban land cover tends to increase and agriculture and forest increase. If we look at the total developed land over time, urban land increases almost 7% between 2001 and 2016. That's an increase of about 443 square kilometers or 109,373 acres. Over the same time period, forest lands decreased by 1.44%, which represents a loss of 232 square kilometers, or 57,293 acres. And agriculture declines by 4.74%, which represents a loss of 317 square kilometers, or 78,357 acres. So again, the rates of change vary, but those trends are relatively consistent over time. So that's our new baseline from NLCD 2016. If you're using NLCD 2016 to analyze trends over time, it is important to remember that the 2011 edition and the 2016 edition are not compatible. That means that when you adopt the 2016 product, you need to download the entire time series and use that as your new time series. Don't take the 2011 edition and just tack on 2016, because the quantities and locations of land covers are different, and so you will not get reliable results. So delete 2011 and just download 2016 and adopt that wholesale. We can also analyze changes on finer time steps because of these extra dates that are included in the 2016 edition. However, urban changes are only captured between 2001 and 2006, between 2006 and 2011, and between 2011 and 2016. That means that any changes driven by urban changes are also not captured. So if you're looking at forest change between 2001 and 2003, you will not capture any changes that might be driven by urbanization. Now, you will capture processes like forest regrowth. So you might see scrub changing into forest. You may see some forests cleared for agriculture, but you won't pick up any changes due to urban processes. So that's important to keep in mind in the Delaware River Basin, because in our case, urban dynamics are a big driver of overall changes in land cover. And again, if you're looking at change, you can start with that change index layer to sort of look at an overall snapshot of total land cover change dynamics. Differences between NLCD 2011 and NLCD 2016 are most noticeable at local scales, and they also vary geographically across the Delaware River Basin, but they don't vary consistently. It varies by land cover class. So when we look towards recommendation, again, the overall recommendation is a DRWI-wide adoption of the 2016 edition of NLCD, and also to think about developing a communication strategy to address why new numbers are different from the old numbers. And that communication strategy might differ based on cluster geography, just because the difference, again, vary geographically. So if you want to know where to get the data, you can go to mrlc.gov/data and download it there, subset it for the Delaware River Basin, and start moving. And if you want to read kind of the science behind it, this is the primary publication that describes this new product. So that is all I have in terms of summarizing the differences. There is a report that's available at our drbproject.org webpage that, that includes all of this detail and more. And there's also, again, a second webinar that focuses on the high resolution land cover data.